Okay, guys, we're starting a new unit here on chemical reactions. I know we're moving quickly. They're already on the third unit here. But this one's pretty basic, pretty simple. It's all about chemical reactions. Okay, so what we're looking at here is the Unit 3 success criteria. I included in the assignment for Monday, the 14th. Yeah, this is really it. It's a really short uh, list of success criteria, and it all deals with balancing chemical reactions and writing chemical reactions. And we'll talk about what each one of these things is as we go along. But today, I just want to start off first talking about what is a chemical reaction. So a chemical reaction, really simple. It's a rearrangement of atoms in molecules that involve the breaking and or making of chemical bonds. And when we talk about chemical bonds, we're talking about exactly what we were just doing before. So ionic and covalent bonds, right? So ionic breaking and making of ionic and covalent bonds. Okay, so that is a chemical reaction. Really simple. Oh, get rid of that. There we go. So here's another example here. So we can have hydrogen reacting with oxygen to make water. Okay, so the bonds between the hydrogens at first are breaking, and same thing with the oxygens, and then we're making new bonds between the hydrogens and oxygens. So just two examples there. Okay, really simple. That's really it for a chemical reaction. That is what a chemical reaction is. Okay, now it's important when we look at a chemical reaction that we have the same amount of atoms of each element on both sides of the reaction. Okay, so on the left-hand side, we always have the reactants, and on the right-hand side, we always have the products. So you'll hear me say this a lot: reactants, products. Hear those terms a lot. Okay, reactants are on the left-hand side, products are on the right-hand side. And again, like I said, it's important that we have the same amount of reactants and the same amount of products. Okay, that's all because of the law of conservation of mass. Mass cannot be created or destroyed, but can be changed from one form to another through a chemical reaction. Okay, so we're just rearranging the atoms. We're not creating any magic here. Sorry, Harry Potter doesn't really exist. So sorry about that, but it is what it is. Okay, so let's talk about balancing reactions. Okay, um, so that's what we're going to be doing in this counting atoms practice worksheet here. Okay, so the first thing we got to realize is that the symbol of an element, if you see a symbol of an element, it represents one atom of the element. Okay, and we know that it's a symbol that we know that it's a new element by a capital letter. If you see a capital letter, that indicates a new element. Okay, if you see a capital letter followed by a lowercase letter, that is still the same element. Okay, so this is just one calcium atom. Okay, capital letters indicate a new element. Lowercase letters are part of the element that's just before it. Okay, do not write calcium as Ca. You cannot write a capital A like that. Okay, capital letters indicate a new element. Okay, so if you're handwriting, if you write like little a's like that, do not do that. Okay, always write it with a lowercase a. It needs to be like that. Okay, if you write all capital letters, you need to change that when you're doing writing chemical equations. Okay, I often see people who have really nice handwriting, but they're writing capital letters all the time, and I have to mark it wrong because you can't write capital letters. It indicates a new element. Okay. Well, only capital letters when it indicates a new element, not when it's part of an existing element that you're looking at. Okay. Next, we have subscripts. Subscripts are the little tiny numbers on the right hand side of the element, and they indicate that the elements are chemically combined. Okay, so we have to be careful because subscripts indicate that they are chemically combined. They have a bond between them. So here, this would mean that there's two nitrogens. Two nitrogens. Okay, two nitrogens. And the difference between a subscript and what we're going to talk about in a second, a coefficient, is that subscripts are chemically combined. Coefficients are not. They are not chemically combined. They're just a number of molecules. Okay. So if we have a subscript, so let's continue with subscripts. If we have a subscript outside a bracket, it multiplies all the elements inside the bracket. Okay, so this one's easy. We have 3 baryons because that's not in the brackets. Okay, and then this 2 multiplies everything inside. So technically we have 2 PO4s. So 2 PO4s. So that means we have 2 phosphorus and we have 8 oxygens. Okay, because we have to multiply them. Okay, really think about it. It's 2 PO4s. We have PO4 and PO4, 2 of them. That's 2 phosphorus and 8 oxygen. Okay, and it only applies to whatever's inside the parentheses, not outside. Okay, a coefficient is a number written in front of a chemical symbol and indicates the number of atoms of that element. So here, 3 carbons or 3C, that's 3 carbons. Okay, these are not chemically combined, whereas this one, like this N2, it means that we have 2 nitrogens that are chemically combined. So we draw a Lewis dot structure like that. This just means there's 3 carbons. So this 3C just means there's 3 carbons. So 1 carbon, 2 carbons, 3 carbons. Not chemically combined. Okay. Next. Now, a coefficient multiplies the number of atoms in each element in a formula. So here, give it 1 second to load there. All right. So here, with this 2 in front of the H2O, that means we have 2 H2O molecules. We have 1 H2O, 2 H2O. So it multiplies 2 times 2 is 4, so 4 hydrogens and 2 oxygens. Okay, this 3 multiplies everything. So 3 irons, 3 sulfur, and 12 oxygen. Okay, and this 4 multiplies everything, but you also have this. This multiplies everything inside as well. It doesn't matter if you go from left to right or right to left. I typically go from right to left for some reason. So I start here. I said 2 times 3 is 6 times 4 is 24, so 24 oxygen. But again, it doesn't matter which way you do it. 2 times 1 is 2, times 4 is 8, so 8 nitrogen. And then this 2 doesn't count for the copper, which is 4 times C, 4 copper, so 4 copper. You could do it the other way too. You could do 4 copper and then say 4 nitrogen times 2 is 8 nitrogen. Then 4 times 3 is 12, times 2 is 24. You could do it that way too. Doesn't matter which way you do it. Totally up to you. Okay. So now you got to practice that with the practice. All right. And then practice that. And then once you're done, come back to the video and I'm going to continue explaining how to balance these reactions. Okay. All right. So now let's talk about balancing these reactions. So I asked you to show work for at least 20 of these reactions. What I'm going to do is I'm going to show you what I mean when I say show work. Okay, the rest of them you can just balance. Once you get good at this, you don't necessarily have to do the work part of it. You can just kind of do it by eye. You get good at it, you can kind of figure it out. So this is what I mean when I say show work. So first thing you're going to do is you're going to write down the reaction. And I always write down the reaction. I put a little line in front of each molecule. So H2. So you'll see that molecules are separated by plus sign or an arrow. Okay, so you have H2 plus, so that means a new molecule. O2. And then new molecule, because we have the arrow, and then yields H2O. So we put a thing there as well. Let me move this down a little bit. Okay, so I put a line in front of each one. Okay, the reason I put a line is because that's the only place we can put a number. All right, we can only put coefficients to balance reactions. Okay. Now, I put a line where the arrow is. Put a line where the arrow is because I separate reactants from products. And in a balanced reaction, we always have to have the same number of reactants as products. We have the same number of atoms of each element on each side. Okay, so again, I rewrote the reaction. I put lines in front of each one. I separated it with a line down where the arrow is. Okay, you don't have to label reactants and products. I just did it right now because, yeah, so you know which one's which. So when I say reactants, you know which one's which, and products. Okay, so the next step is I have to count how many atoms of each element I have on each side. Okay, so here I have, right now there's imaginary ones in the front of each one. There's imaginary ones. We're just going to assume that there's one of each. Okay, so here I have 2 hydrogens and 2 oxygens. Okay, on the product side, I have 2 hydrogens and I have 1 oxygen. Okay, so that'd be the next step, is to count the number of atoms on each side of each element. All right. Now, you'll notice that I wrote the hydrogens at the same spot and the oxygens at the same spot. That is a preference of mine, and I highly encourage you to do that because it makes it a lot easier to see as you get more and more elements. It makes it a lot easier to see if you have the same number of each, because that's ultimately what we want. We want the same number of each atom on each side. So you'll notice here that we have 2 hydrogens, so those are good. We have 2 oxygens and 1 oxygen, so those are not good. Okay, we need to get this oxygen to be the same as this oxygen. So in order to do that, the only thing we can change is the number in front. That's why I do these lines. We can only put numbers in front. We can only change coefficients. We cannot change subscripts. Never, ever, ever change subscripts. If you change subscripts, you change the molecules. We don't want to change the molecules. We just want to add more of reactants or more products. Okay, never change subscripts. Okay, so we're going to put a 2 here. 2 times 2 is 4. That changes that. And then 2 times 1 is 2. So essentially what I'm doing here is I'm putting a coefficient, and then I am recounting. Every time I put a coefficient, I have to recount. I have to recount the number of atoms of each element. And you'll notice that sometimes, yeah, I put a 2 here and it made the oxygens even, but it screwed up my hydrogens. And that's okay. It's okay. That's going to happen a lot. Okay, so now I have 4 hydrogens on this side. I have 2 over here. So now I need 4 over here. So I'm going to put a 2 there. 2 times 2 is 4. Okay, so now you'll see that we have the same number of hydrogens on both sides, same number of oxygens. So this is our balanced chemical reaction. 2H2 plus O2 yields 2H2O. If it makes you feel any better, you can write a 1 here, but you don't have to write a 1. Okay, anytime you don't see a number in front, it's just assume that it's a 1. Okay, there's no reason to write it if it's not actually there. Okay, so that's what I mean when I say show work. Okay, let's do one more. Okay, we'll do number 2 here. So again, I write it with the lines in front. S8 plus O2 yields SO3. I put a line down where the arrow is. I count the atoms. So S, I have 8 S's. I have 2 oxygen. On this side, I have 1 sulfur and 3 oxygens. Okay, so this one's a little bit tricky, right? Here we have 8 sulfurs, 1 sulfur, so let's make this an 8. That makes this now an 8, and then this 3 times 8 is 24. Now to balance the oxygens, don't look at this to balance the oxygen. So sometimes people look at this and think, oh, okay, I need to multiply this. But don't look at that. Look at what's here. I have 2 oxygens. I need to get 24. So what number do I need to put here? I need to put 12. 12 times 2 is 24. Okay, and now these are even. Okay, that's the very basics of balancing reactions. Okay, I'm not going to teach you any tricks or tips right now. What I'm going to let you do is I'm going to let you try and work through as many of these problems as you can. I want to see at least 20. So show me the work for 20 in this assignment. You don't need to finish all 50. You just have to do 20. Show the work for 20. Doesn't matter what 20. Just pick 20 that you're able to do. Show the work for the 20 that you're able to do. Okay? Give those a shot. And then I'm going to teach you some tips and tricks and hints afterwards. Okay? But it's best that you struggle for a little bit. I know that's kind of mean, but it does help to struggle for a little bit. And then I'll kind of teach you some little tricks along the way. All right. And that is all I got. Good luck with that. Let me know if you need any help.